Good morning, everyone. I am Devaki, Assistant Professor in the Department of VCE at K.S. Rangasamy College of Technology. Today, I am going to present you my topic of slew rate, which is one of the important performance parameter of an operational amplifier. This is the introductions about. In this slide, I will explain the basic concept of slew rate. Slew rate is an important frequency-related parameters of an operational amplifier. If defined as the maximum rate of change of the output voltage with respect to time, it indicates how fast the output voltage can respond to changing the input signal. The unit of slew rate is volts per microseconds, written as V per microseconds or V bar microseconds. A higher slew rate means the op amp produces a faster output changes without distortion. This slide shows the effect of the slew rate. When the input signal changes slowly, the output follows the input accurately. However, if the input changes very rapidly, the output cannot change faster than the specified slew rate. As a result, the output waveform becomes distorted. The phenomenon is known as slew rate distortions. Therefore, the slew rate limits to the maximum operating frequency of an operational amplifier. The next one is now let us see why slew rate is occur. Inside the operational amplifier, there is an internal compensation capacitor. This capacitance improves the stability of the amplifier and it prevents oscillations. Since the capacitors can charge and discharge only with a limited current, the output voltage cannot change instantaneously. The rate of voltage change is given by dV by dt equal to IC by R, where is the I is the charging current and C is the capacitor value. The maximum rate of change of output voltage is called the slew rate. The equations become SR equal to dV by dt at a maximum change of voltage, I max by C. These equations tell us that the slew rate is increases when the charging the current increases and decreases when capacitor's value increases. Now consider the sinusoidal input voltage. The input voltage Vs equal to Vm sin omega t. The output voltage V0 equal to Vm sin is omega t. The rate of change of output voltage dV0 by dt. The differentiate the output voltage in terms of with time divisions Vm omega cos omega t. This equation shows the output voltage changes continuously with the time. The maximum value occur when the cos omega t equal to 1. Therefore, SR equal to omega Vm. So, omega in terms of 2 pi f. So, slew rate SR equal to 2 pi f Vm. This is the equations we can calculate the maximum frequency at which amplifier can produce the undistorted output. This frequency is called as a full power bandwidth. The higher slew rate result in a higher full power bandwidth, allowing the amplifier to handle the high frequency signal more effectively. Okay, this is bring to me a end of my presentations. To summarize, the slew rate defines the maximum speed at which the output voltage at an operational amplifier can changes. Its important parameters is high speed electronic circuits because it determines whether the amplifier can reproduce the rapidly changes the signals without distortions. Thank you for your attention. If you have any questions, I will be happy to answer for them. Okay, thank you.